Hi, we're excited to be here at Espresso's DevCon 2022, and we're going to be talking today about thousands of ESP32s device management for ESP-IDF based devices. My name is Chris Gamble. This is my coworker, Mike Stish. We both work at Goliath, and we have really enjoyed working in the ESP-IDF recently. We'll be talking about that here in a little bit. So first things first, let's just give a little background about who we are. If I can find my mouse. My name's Chris. I've been working in hardware a long time. I now work at Goliath in the developer relations group. If you have a hardware background, you might know it kind of like a field applications engineer, that sort of thing. But basically, Mike and I, we make demos, we make videos, we make blog posts, and we talk at conferences, and we love talking about it. Mike, how about you?
Yeah, my name is Mike Stish. So I am a developer relations engineer at Goliath along with Chris and have a lot of fun there playing with microcontrollers. I started off in the early 2000s with the propeller microcontrollers and moved on to the AVR. I was amazed by the speed of the AVR. So you can understand that the Espresso chips kind of blow my mind. Also, just what we're able to do, like connecting these microcontrollers up to the internet and doing amazing things with them. Boy, I wouldn't even have thought this was possible 15 years ago. So having a great time with it.
Great. Finally, Nick Miller is our lead firmware engineer. He's not here today, but he is the author of our Goliath ESP-IDF SDK. He had glowing things to say, which we will relate later in this talk. Nick had some past experience with the ESP-IDF ecosystem, and he was able to turn around our SDK very quickly, and we've been very, very excited about it. So we're going to show some of that here today. Speaking of showing here today, let's talk about some of our learning objectives. So what are we trying to see in this talk? We're going to be talking about large fleets of devices. And even if you don't have that, if you only have one Espresso device on your desk, well, first off, buy some more. They're great. And as you start to grow, or as you think about it, even maybe you're like, maybe in 5 years I might have a bigger device fleet. One of the problems is you don't know what you don't know, and that's what we're here to kind of talk about today. What are some of the challenges around growing a device fleet? As your device fleet gets bigger, what do you have to deal with, and how might things change? We're also going to do a demo. Mike's going to do a demo about Goliath and how we kind of work with that stuff, how we have some simplified functions to make control of your devices easier. Well, actually, what is the next point here? We make it easy to collect sensor data, to control individual devices in and amongst thousands of devices, and do the critical thing like over-the-air updates. That's another thing that people really, really seem to like about Goliath, and it was very easy to implement in ESP-IDF. So let's talk a little bit about you. You are probably someone who is interested in hardware and firmware, even if you have a different background. If you're interested in Espresso, you probably are a fan of the hardware like Mike and myself are. But you probably don't want to become a cloud expert. So if you want to control one device, 1,000 devices, 1 million devices on the cloud, otherwise you probably do need to become a cloud expert. We think we found some ways to reduce that barrier to entry, and you still might want to then go and actually talk to all the devices that you have out there. So it's going to depend on your application, depend on how many devices you decide to do. But let's assume you're going to be putting thousands of devices out in the field. And let's talk about some of the challenges about that. Some of the things that you do when you have 1 or 10 devices on your bench, it starts to change. The nature of those interactions change at hundreds or thousands of devices. And one thing that Mike and I do is we talk to users both around the ESP-IDF SDK that we developed, and also other programmatic ways that people can make their devices talk to the cloud. And a thing that comes up a lot, I think Mike will agree with me here, is scripting, right? So scripting is like this, I can write a Python script, talk to REST API, make it do this, make it do that, maybe even control the hardware over a UART or similar. And that's great. It actually does work. You can do that out to 1,000 devices, thousands, millions, whatever, but it just gets more complex and more opaque. So if you are potentially telling all of the devices you have in the field to go and update their firmware, maybe go talk to an S3 bucket, that's a common one that I've heard. That's great, but then you also need to put in tooling for, did they actually all do it? Which ones worked? Which ones didn't? Which had problems? Which are still kind of hanging in there? Maybe what is going on with the network in order for them they couldn't download the entire image. And so putting some other stuff in place there can make that a little bit more clear, and that's what we aim to do. Another thing is, as your team grows, so if you imagine you have 1,000 devices in the field, maybe you have a business you're starting to build an IoT deployment around, well, you're going to need to hire people eventually, maybe for deployment, for monitoring, whatever it is. And even if you have the same skill set, you might not have the same deep domain, the same deep expertise around the actual deployment itself. So Mike and I Mike is much more skilled than I am in a lot of areas, but if I'm the one who designed the device and the firmware, and then I ask Mike to come and help me, I have a little bit more kind of in-depth knowledge of how I built things, where the demons are, that sort of thing. And then I bring in other people who are skilled or unskilled, and I want to make it easier for them to be able to help me out and interact with the devices. Another thing we see often is resources that are installed locally. So what I usually think about here is like a Node-RED instance that might be on a Raspberry Pi on your local network, or maybe on your computer. It needs to scale by being out on the cloud, right? So you need to be outside your firewall, but also you need to have kind of larger implementations of this, and that can be dangerous or hard to manage. But basically, while Node-RED, Mike and I prototype with Node-RED a lot. Getting past tens of hundreds of devices, it's possible, but it just becomes more burdensome. And so there's other ways to go and actually control devices and react to them and forward data along that we think we found some other ways to do that sort of thing, but we want to help explain what that looks like. When you do have thousands of devices and they're all sending stuff back, so Mike's going to be showing a demo here that's sending, I think every 5 seconds. Is that right, Mike? At the beginning?
Yep, that's how it starts.
Yeah, so every 5 seconds it sends at the beginning. Even at that, every 5 seconds from one device throughout a day, throughout a week, throughout a year, whatever, it's a significant amount of data for a single device. And now as you're linearly scaling your actual deployment, that database starts to get really, really big, and thinking about how you want to manage that data. When do you want to cut it off and start deleting the old data? And it just seems more and more like a job. Speaking of linear growth, as your device your fleet size grows, and it scales linearly, your time doesn't, right? So I might be able to look at 10 devices blinking on the desk and say, oh yeah, they're all online right now. But when it's 1,000, they might not be in your desk in the first place. But even if you had 1,000, it might be hard to pick out the one device that isn't blinking right now. And so you think about being able to monitor each and every device. Your time is a very valuable thing, and you want to be able to see that device health. Finally, we already talked about firmware updates a little bit, but plugging in one cable to update a device, that's fine. But doing it 1,000 times, that's probably a week plus of work. And depending on where your devices are, and if they're installed up on a big tower, that's a long cable you need. So one of the things that we think can help with all this is Goliath, the company that we work for. It's a device management platform, and we're trying to solve a lot of these scaling issues. One of the things that we see is kind of balancing the ease of use and programmatic control, because what we were talking about with scripting is kind of programmatic control. Ease of use might be more of a UI base. We actually think that we can do both, and so that helps you to scale between having more people on your team. You might want to allow more people on your team to manage devices on things like our management console. But then as you want to roll out big changes to the rest of your fleet, you can then programmatically go and access our REST API, which makes it easy for that scripting or for things like apps to go and talk to our devices, which is actually something Mike is about to show. So Mike, take it away with our demo, and we'll come back to the slides here in a second.
Yeah, so I'm going to take just a moment here to get my camera switched over. And let's see. All right. How are we looking, Chris?
Excellent, like usual, Mike.
All right. Thank you. Okay. So we have on the bottom right corner here, this is a live image of the ESP32 C3 Dev Kit C. This is a wonderful board you can get from Espressif. If you don't have one already, you should definitely pick one up. It, of course, has the Wi-Fi modem in it. That also has a core temperature sensor, which we're going to be using for streaming data, and an RGB LED light that we'll get to in a moment for user feedback. So if I just hit the reset button on this, we can see the bring up. It's looking for Wi-Fi right now. It's going to attach to my Wi-Fi point. This particular example does a few things at the beginning. So it looks for over-the-air updates, and it's going to wait until it gets a firmware revision. So it's to see if it should do an update or not. It also downloads some settings, and we'll look at that all in just a moment. But for right now, these core temperature readings are the thing that I think is the most interesting. So, a lot of IoT devices have a sensor, get some data, get that back to the server. So if you're talking about thousands or millions of devices, you want to be able to do that. You want to be able to handle that data. This is the Goliath web console, and I'm looking on here just for this device, and I can go into our LightDB stream, which is a time series database, and I can see I'm getting these timestamps that go along with the data that's coming in. Now, I like to show this view because you can see this is a JSON object. You can send complex JSON objects. So if you have numerous readings nested and all that sort of thing, you can use that just fine. But for today, I'm just doing a sensor with one data reading. But this is just for this device, and we're talking about managing thousands of devices. So I can go and see the same stream, the time series database for all of the devices that are reporting. And in this case, it's two for the demo. One is on Chris's desk and one is on my desk. And I can do the automatic refreshes on these. Let me make sure I'm in the last 4 hours. And we'll see the settings is my device, and the Chris is Chris's device. And you can see these coming in about every 5 seconds on the timestamps here. The thing about this data is it's not very compelling to just watch the numbers go down, and it's maybe not easy to tell whose number goes where. If you're trying to proof something out for your boss or get a customer to say yes to a contract, you might want to do something more graphical like this. So Chris talked about the REST API. This is along those lines. I'm using an API key and our WebSockets to get live data as it comes real time from both devices. Chris and I are not in the same office. We work in different parts of the country, yet I'm able to both see and control his device. Let's talk about that device control. So I mentioned that we have two types of databases. So if I go back to my device settings, we can see the stream is what we're looking at for our core temperature, but the other one is going to be state. So this is like, is the LED on or is the LED off? This is stuff I don't really need to know over time. I just need to know what's the setting at right now. And for my device down in the bottom right here, this is actually registered to observe this desired endpoint on the web. And so every time this updates, the Goliath servers are going to tell this device, hey, your data just updated. And the data I'm actually looking for is LED 0. And I can set that to a value. And as soon as I click submit, we should see the device reacts by the blue LED coming on. You'll notice that that endpoint, it was deleted by the device to indicate that it got that command. I can do the same thing again in order to turn it off. And you'll see that data is gone. So this is great for testing for one devices or two devices, but what if you're trying to control lots of devices? So one of the things you can do, similar to how I did this graphing on Grafana, which is an external platform, I actually found this web app, this Android app in the App Store. This is called Home Habit, and it lets you assign buttons to REST API calls. And so I've got one that is a button for turning on my LED right here and another for turning off. Now, if you watch when I press this button, you're going to see this desired value will be set. And that's because the REST API call is what's being used on the dashboard as well. And it's what controls the endpoint that the device is listening for. I have the ability to do Chris's as well, but I think you've seen enough LEDs go on and off.
I have it up right now if you want to show it, Mike.
Oh, yeah. Okay, so we should be able to turn
my face just so it's in. Yeah, there it goes. It's on. Yep.
Yeah, Chris is on, Chris is off. And because this is a REST API call, I'm calling the exact devices with these buttons, but I could call groups of devices. I could call the entire fleet. I could have the LEDs for a million device fleet come on with these. Whatever API call you want to run will be fine right there. So that is device state and running some API calls on there. Probably one of the biggest that we hear customers looking for is the ability to update firmware. So like Chris said, if you're going to plug a USB cable into a device, that might be fine for 10 devices. But if you get to 1,000 or 100,000, you're in big trouble. But not with Goliath. We've got it all figured out. So here you can see I'm actually using a blueprint on these artifacts. The artifacts in this case are all firmware binaries that we've uploaded. And I'm telling it like, hey, I've given a blueprint to certain devices. So if those devices are listening for updates, this update is the one they're looking for. Once I have those, I can create a release. Here we'll see our blueprint again for our ESP32C3 dev kits. And both Chris and I are running the 1.2.5 right now. I have another release available, 1.2.6, but I haven't rolled it out yet. And so when I actually click the rollout button and I go back into my IDF monitor, you're going to see that it will tell us it's running the current version 1.2.5. It's going to find out from the server that 1.2.6 is now available. And we actually see it's downloading blocks. So it's going to go through, download this, verify it, and upgrade to this. I don't think we have time for that right now on this demo, Chris. So I'm actually going to turn that back off again. and the device will, I've just clicked reset, so the device will stop trying to update on it. But this is another feature that I think is really interesting. If you roll out firmware and you tested it, it works, but you realize you made a mistake, like you got a decimal point in the wrong place on your data or some other reason that you don't want it running on production. Instead of having to like go back and find on GitHub the last hash that was working and compiling it and testing it and pushing it out again, you can just do a one-click rollback, and the devices are going to be notified, oh, 1.2.6 is not good anymore. They're going to find 1.2.5 is the last known good one, and they're going to download that and start running it. So a lot of peace of mind there for devices in the field and what you're doing with the updates. Another thing when I think about devices in the field is like how to troubleshoot them. So you might want to be able to get logs from your devices. Well, if you don't have a USB cable connected for the monitor, how are you going to get these logs that are coming out? And Goliath actually has a logging service for that. I can go and look at it. You can look at it by device or by the fleet. I'm just going to look at it by device here. You can see these log messages that have been coming back. I have debug messages set up for reading the temp. I can filter those out. So I can just look at my info messages, which tell me like when the app came up and some more about the state of it. And of course, if you don't want to have all of these, think about millions of devices sending debug logs. That's probably not a great use of your database. You're going to have trouble finding things in there. You can just turn those off or set the debug level remotely. In this case, I'm not setting debug level. I could here. I instead set the delay between sensor readings. So Chris mentioned before, there's 5 seconds between sensor readings. Now I could change this right here, but this is only going to affect this device. However, as with the other things we've been showing, there is a device settings option for the fleet level. And so I'm going to go ahead and reset this from 5 seconds to 2 seconds. And if we look on the monitor, we see already this device has seen that. Chris's device will have seen that as well, where he's at. And if I go back and look at the incoming data, we can see now our timestamps, both Chris and I have changed to 2 seconds in between readings. So like if you wanted to set your log levels, you could change and say, okay, debug levels I want just for this one device, or you could say I want all devices to only send error. You can also do by groups of devices using those blueprints as we looked at before. I think the last thing that I want to look at is the remote procedure call. So this is really a great way to interact with your devices. So in my case, I have just implemented a function called reboot. And we'll look at all of this code in just a moment. But I can send a reboot message to my device, and it got that, and it's going to reboot in a few seconds here. The great thing is it's also going to tell me it got the message at this timestamp, it took this long to react to it, and the status is okay on this. You can also send parameters. So if you want to, send some commands in with whatever your function is going to be, you can work with that, and then you can get data back as well, and you'll see that displayed here. So this is wonderful for things like, oh, I want to check RSSI values of the Wi-Fi for this one device because I've been having problems with it. Why don't I send a remote procedure call and have it, tell me like what's going on with the signal or whatever other thing you're doing. Yeah, that's a lot. Chris, do you think we should roll on to the next part and look at some code?
Yeah, let's look at some code. That's great. Okay, so we're going to go back to our slides here. And we're going to talk a little bit more about what Mike had shown you on the actual Goliath console. So remember the console.goliath.io, that's what Mike was just showing for a lot of that management, that GUI-based interaction. You also Mike showed some REST API interactions as well. So that's really that balance point between making it ease of use and being able to target individual devices and kind of understand everything that's happening around a device without having to do lots and lots of scripting there. All right, so let's talk about some of the things that Mike showed there and really the concepts of getting data on and off of devices. So the first one was LightDB state. And this is how Mike turned my LED on from, I don't know, what we have 1,000 miles apart, Mike? I'm in North Carolina.
Yeah, something like that. And I would like to mention, Chris, that all this Goliath SDK is built on top of the ESP-IDF. So you just include it as a component of your ESP-IDF project, and then you get these kind of like one-liner commands. And so in this case, like sending data from the device to Goliath is the top line, the set int async, and then getting data data back is the bottom one, which is you tell it where to put the data. And also in this case, it's a synchronous. So we have both asynchronous and synchronous API calls. This one will wait 5 seconds before it gives up waiting for the server to come back. But you notice the top one is asynchronous. I didn't put it on here, but there's a way to observe these states as well. And in those cases, you set a callback and you just register the callback with one line. We'll see that that pattern in just a moment.
Yeah, Mike brings up a good point too, is that all the code you're going to be seeing here is device side code. And there is no server side code because all of the interfaces, all of the endpoints that you're talking to, and really all of the tooling and infrastructure behind it, that is all taken care of for you by Goliath. So whereas you might be used to writing like Lambda functions or similar, or snippets of Python you have to go and kind of maintain on the server, this is all device side code. And so to call back to the beginning of the presentation, when I said as a hardware person, I don't want to have to become a cloud expert. This is a good example where enabling just these single lines gives you all this stuff. In this case, being able to control a wide range of hardware that you have out in the field.
LightDB Stream is the other type of database we were talking about that's time series data. So it's going to have timestamps, and you're going to be able to graph that data or do whatever other type of filtering that you want. And in this case, just a single line call. So I got the T sensor out value here, and I'm just writing that to the temp for temperature endpoint. And so every time you need to push something up to the cloud, you can just send this command. It will assign the timestamp automatically, but there is also the option for you to include a timestamp and a JSON object. So if you're caching sensor readings and uploading them later, you can get the right timestamps in your database.
Yeah, we've done that for GPS examples in the past where the satellites give you their timestamp, you store them and move on. I think this is a great example of just that, it's basically like a server.write, it's like a pseudocode kind of application there. And then you get access to all of this data on the server ready to go. And we'll show some other options for seeing that later.
The setting service is what we used for changing the seconds delay between the temperature settings. Reading the temperature sensor. So you could do this, like I said, for changing like the log level of what is being sent back to Goliath. And in this case, the upper block on the left is the callback function. You can see in there, I'm just checking for a specific endpoint, the loop delay seconds endpoint. And if I get that, I will go off and do something in my code. I'm actually just changing a global variable. I took that out for this example. And then otherwise you could return that the setting was not recognized, and then Goliath will know whether or not your settings are in sync. There's a place on the dashboard for that. The bottom line is the one-liner for registering that you're going to use the settings and telling it which callback to execute. Yeah,
I really like that this is the arbitrary code piece of it, right? So you could kind of put a lot of different things. You can call other functions. You could kick off a task, that sort of thing. That's what we do for the reboot function. When I think about like a large scale deployment, like your example of RSSI is great because you might not want to be sending back RSSI every single time you publish all your data, but you can do it on demand then. And so you could really think about how you might want to be debugging more of your device. So you kind of have submenus on submenus to really dig into what's happening. I'm getting this confused with the RPC right now.
RPC, yeah.
Yeah, sorry, that's the next one. On this one, you could really imagine having a wide range of available settings and being able to target each and every one individually.
Yeah, you could also have streaming data.
The gun on that one, Mike.
Well, you could have streaming data for your RSSI already set up, and you could use the settings procedure to just turn it on and off. Like you could turn a whole bunch of debugging features on and off, and have like a whole suite that's just waiting there, and have the settings service like, oh, this device, turn it on, or you could be like, all the devices that are in Akron, Ohio, turn this on, and have a lot of
turn on debug mode, and then it floods. Yeah, gets you a whole bunch of data to help.
Yeah, because I mean, again, you don't want to have someone drive out to the plant and hook cables up to your devices. Like you want to be able to do as much as you can to fix the thing without going there as possible.
That's right. All right, now the thing that I jumped ahead to.
Yeah,
I'm so excited about it.
Remote procedure call is, I think, when you need a little bit more interactivity, right? So for instance, like you might have multiple Wi-Fi networks that you're trying to spec out, but you don't know what they are at compile time. So you can't just set up, turn it on or turn it off. Remote procedure call, you could send something that says, hey, look for this Wi-Fi network and tell me how strong the signal is, and then send that information back to me. Like there's a lot of utility here for you to not just run a function, but to run a function with parameters that you weren't thinking of when you programmed the device.
Yeah.
And of course, you're not stuck with what happened when you first compiled the firmware, because you can just compile new firmware and send it to the device. In this case, I'm blown away by how easy this is on the ESP-IDF SDK. Literally, I just tell it the current version so the device knows what firmware it's running. And then this one liner below that tells the Goliath servers, hey, I'd like to know when you have a firmware update, inform me. And so you will just get a push notification from Goliath when a new version is available, or like the next time you power up, if you're in low power mode, it will always check on power up and you'll be able to automatically do firmware updates.
Yep. Cutting down on cables and plant visits, like you mentioned. Let's talk a little bit about, once you have that data on the cloud, other things that Mike kind of covered here. One thing is the concept of blueprints, and really this and the next item are ways to kind of slice and dice your deployment. So when you really want to have a targeted strike just at the devices in Akron, like Mike mentioned, you might have those tagged. That's the next one here is tagging. You might have them tagged as Akron, but you might have 3 different types of Espresso devices out there. You might have a ESP32 C3, original ESP32, and an ESP32 S2. And you might want to be able to narrow it down to just the C3 devices. I only want to see those, or I only want to see the ESP32 C3 devices in Akron. You could start to really slice and dice your deployment and understand what's going on, even instrumenting it off platform in something like Grafana as well. Mike also showed this with the multiple viewpoints and seeing the streaming data come in. You might want to prototype what that looks like, being able to, we are showing a single sensor reading, but I've had some sensor platforms that had 50 different parameters that were being sent back to the cloud, and you want to understand which ones you're using, how they're working hierarchically, and how you might be exporting them to different places. And finally, on the export side of things, we do work with, we have native integrations with things like AWS SQS, Azure Event Hub, and webhooks, GCP, and an ever-growing list of those. But we realize that most people are going to be working with a cloud-side team that they might want to export that data to in the future, and we want to make that really, really easy. On the choice to make the ESP-IDF SDK as part of Goliath, we decided to build it because we saw a vibrant community, obviously as part of this event, but also a well-developed ecosystem in the ESP-IDF. We've been really impressed with that. And this is some of the stuff that Nick wanted us to pass along as the author of our SDK there. One thing that really helps a lot here is standardized setup across hardware. So even though there are multiple product lines and all ever growing, the kind of standardization in the ESP-IDF has been really useful. Being able to work with a well understood version-free RTOS with a networking stack, embed TLS, and then an external library. That's kind of the listing of the requirements to go in for us to build an SDK. We need to be able to send secure messages back to the Goliath cloud because we're secure by default, and we need to be able to have an understanding of all of the variations in the hardware we may see. It was easy to pull in CoAP support using that library, and really Espresso just did a great job with testing and building this ecosystem for us to build upon. Not only that, example code was really useful, especially a CoAP client. So Goliath operates with CoAP endpoints as opposed to something like MQTT. We think there's a lot of benefits in terms of lower data overhead. Again, when you're scaling, you might not care about a couple kilobytes here, kilobytes there, but thinking about the data traffic and all of the compression that might happen with CoAP versus MQTT, UDP versus TCP, all of those kind of different things there. We really like working in CoAP, and you'll see that in some of our examples. The great documentation, though, and being able to tap into the community has been very, very helpful. So we're very interested in helping people hyperscale to your device fleet. 100 devices, 1,000 devices, 1,000,000 devices, 100 million devices. We're here to help you with that. We can always talk to you about that sort of thing. Mike and I, as I mentioned at the beginning, DevRel, developer relations, we write a lot of content, not just about the Espresso ecosystem, but also all of the things that we cover and some of just kind of general interest points as well. We do recommend you check out our blog.goliath.io. If you sign up for the console, you actually get subscribed to that, and you'll see stuff come out every Tuesday, Thursday on the blog, and we have a newsletter every 2 weeks. And finally, you should please try out the console. So it's all free, up to 50 devices, and our dev tier gives you those first 50 free. We think that's a pretty good size, and you start to see some of these scaling problems at that point. Thanks for having us. We really appreciate it, and we're really excited about the future with Espressive and DevCon 22. Mike, any other thoughts?
I just had a great time. It's been wonderful being here. Thank you.
Thanks so much.
Okay, so let's add the guys from Goliath, Mike and Chris. Hello, guys.
Hello.
Hey.
Perfect. It was an interesting talk, nice demo, and so on. So let's just start with the questions. We have the first one from the audience, and it's is the website customized to each client?
Yeah, so we actually have projects that you can switch between on the dashboard. So if you have multiple customers, we would recommend that each goes on their own project so that their devices are separate from each other. As far as customizing a dashboard, everything on our website is using an API to be displayed. So anything you see can be built into your own website, or if you want to, so you could then do a different branding and a different look for each customer. But we also have the ability to do output streams, which make it very easy to connect to other sites. Chris, I think like DataCake and Ubidots both do that kind of like custom customer dashboard option, and we have built-in integrations for those.
That's right. And I would also say, so like Mike said, so say you have a consulting client, maybe you have like a couple consulting clients, they each have their own project, but one of them gets really big, right? They hit the jackpot, they have 1 million devices in the field. We also, really cool thing about Goliath is it can be deployed onto your own AWS servers or your own Azure servers. And actually, because it's, Kubernetes based, you could basically go and install it on any, you could install it in a server closet as well. So basically taking that exact same code that, your ESP devices are talking to, the Goliath endpoints and things like that. You could take that and then install it into a server closet, for instance, and have a local deployment or a really massive deployment if you're on Google Cloud or AWS or whatever you wanted it to. So, so short answer, yes, it can be customized to each client.
Perfect. From the point of the beginner, at the very end, you have mentioned that you can just start for free with 50 devices and just sell your first fleet. Can you maybe explain a bit more, like how can I just like start step by step?
Sure. So the easy way to do it is you can sign up on console.goliath.io. That gets you, your first account and those 50 devices. From there, you're going to create a device and you'll get credentials that then you're going to be putting into ESP-IDF. So once you compile your code in ESP-IDF, you put that on your ESP32. Then there's a time when you're going to give your Wi-Fi credentials and your Goliath credentials so that you're verified to be on the network. And really, it's all about getting that first device on there. In the ESP-IDF, like Mike showed in the demos as well, there's a bunch of, in the Goliath basics thing, all of that sample code that we were showing there is already there, so you could start to see things like light DB state showing right away.
Okay, perfect. We have here a few questions from Espressive. So the first one is, recently the support for ESP-IDF was added on Goliath. How this experience has been for you?
Go ahead, Mike.
Yeah, it was a really great experience. I talked to Nick Miller, who is our lead firmware engineer and developed the ESP-IDF SDK for Goliath. And he recounted that it was a great experience because a lot of the things that were already built on, like CoAP was already in there, Embed, TLS, and DTLS were already in there. And then there were great examples that he was able to follow, like how Espressive and ESP-IDF handle firmware updates. So building the over-the-air update service of Goliath into the ESP-IDF was like, it couldn't have been easier, I think. And so anybody that's looking to do an integration, this is a great ecosystem to be in.
Okay.
Yeah, and I would say as well, like, so Mike and I do a lot of Zephyr stuff. We were switching over to ESP-IDF and it was just like, it was a snap to just like understand what was going on immediately. All of the tooling, super awesome. So really, really great polished product.
Okay. Let's continue with the next question. How do we send JSON data to the Goliath cloud service and also connect it to integrate it with Google Assistant, for example?
So JSON data to the cloud service is simply putting formatting your string. So I use like an SN print K type of statement to format my string into JSON, and that just builds in, like the curly brackets and quotes around strings and that sort of thing. Once you have that string, it's a one-line command to send it to Goliath, and usually we're sending those to the Goliath stream, which is a time series database. So if you think about sensor data, you want a reading every 5 seconds. You want to know the timestamp on that. If there's, we also have a state database. So if you're like, is the LED on right now? It doesn't really matter as much when the LED was on or off. You just want to know the state right now. Both of those, you format your JSON. You just call the function that sends it there. As far as integrating into Google Assistant, that's Chris. What are your thoughts on that part of it?
So I think then you might have to, the Google Assistant stuff, we don't have any native examples for that. But I would imagine that, so say you were trying to control, like Mike said, an LED on one of the devices that's out in the field. If you had some kind of external service that's talking to Google Assistant or handling the incoming from Google Assistant, then in order to turn the LED onto device 22 that's in Akron, Ohio, like Mike had mentioned during our talk, basically you could access that directly through the REST API. And so to actually turn on an LED on device 22 in Akron, Ohio, it would just be able to query where that device is, and you already verified that you're able to talk to the REST API through our API token that we issue, and then you can flip that LED from 0 to 1.
Right. For a lot of other integrations that I've done, I've used our WebSockets because you get real-time data updates. As soon as data is received from the device, Goliath will send it to any WebSockets that you set up. As far as accessing, Chris mentioned the REST API. We also have webhooks set up and a bunch of native integrations to different cloud services. I'm just not as familiar with plumbing it directly into Google Assistant.
Okay, so I have like 2 last questions for you. The first one, hello there. Does Goliath have support for ESP-S3 voice recognition?
Not that I know of.
I think that would come from the ESP-IDF itself. So if there's support in the ESP-IDF, you can then use that support and send it to Goliath, because Goliath is just a component that you add into your ESP-IDF project. So if you have an existing project, add it in, start using those APIs to send data up to the cloud and get control back.
Okay, and the last question, do you plan to have support for TLV alongside with JSON?
I don't know what TLV is, sorry.
Well, so if you're asking about serialization, we have CBOR serialization. So a lot of people don't want to use JSON because it makes the packets larger. And Goliath also has support for cellular devices. And built into that, we use the CBOR serialization to make sure the packets for your bandwidth are as small as possible. And of course, that CBOR serialization is also available for any of the expressive parts that you're using with Goliath.
Okay, so I think that's it. Thank you, Mike and Chris, for joining us, and see you soon. Bye-bye.
Thank you. Appreciate you having us.
And now we will have 10 minutes break, and after that we will just continue with the last block of the talks.